So, do you believe in aliens? The issue of space debris is becoming a growing concern.
Will there be a traffic jam in space?
Sir, as you mentioned that sun has a limited age.
So it is very close to the botany, geology, geology, social science, economy, law, management, whatnot.
Hi everyone, I am Saurabh Jha, a research scholar at IiT Indore from the Department of Astronomy, Astrophysics and Space Engineering. On August 23rd, our department will be celebrating National Space Day. I am honored to welcome our special guest for today's talk, Professor Anil Bhardwaj, who is currently the Director of PRL Ahmedabad. Sir, first of all, I would like to express my gratitude to you for taking the time to join us today. And sir, I also want to congratulate you on receiving the prestigious Vikram Sarabhai Medal recently. So, sir, as you know, we are going to celebrate National Space Day. It would be wonderful to hear your thoughts on the significance of this day for India, especially given our country growing achievements in space exploration.
Okay, so as you all know, the government of India has announced 23rd August as the National Space Day. And this is actually to celebrate and commemorate the first soft landing from India on 23rd of August 2023 at 6:04 p.m. The Vikram lander actually landed in the southern polar region of the moon. And that made India the only country or the first country who has made the soft landing at this latitude in the southern polar region. And that is why it's a very important day for India and for the whole world, because now the whole world is aware that there can be landing in this kind of regions at higher latitudes, since no other landing has happened. It is technologically challenging to do that also, because of many issues, including the lesser amount of sunlight, the communication issues, and things like that. And that India has not just done the soft landing, but its lander worked for continuously 12 days. And the rover which was sitting inside of the Vikram lander and moved onto the lunar surface for next 12 days and provided us a lot of good science. So to celebrate the whole mission success, Government of India has declared 23rd August as the National Space Day.
Sir, as you mentioned about the Chandrayaan 3, and it has been a significant milestone for ISRO. And it's building on the foundation laid by Chandrayaan 1 and the lesson learned by Chandrayaan 2. Despite the challenges faced by the Chandrayaan 2, how did it contribute on the success of Chandrayaan 3? And what have been the key achievement of this mission enhancing Indian standing in the global space research?
Of course, the Chandrayaan 3 is built on the legacy of the Chandrayaan 1 and Chandrayaan 2. Chandrayaan 1 mission, as you all know, is a very important and celebrated mission, not just for the country, for the whole world, essentially because it discovered water on the moon. We had Apollo landings in 70s, 60s, end of 60s and 70s, and subsequent several missions have gone there, including landings. But we were not sure that water exists on the moon. And it is only the Chandrayaan 1 mission which confirmed that water exists on the moon and that it is there in the ample amount. So that's why Indian mission is celebrated worldwide. The legacy of the Chandrayaan 1, which was essentially an orbiter, continued for Chandrayaan 2 mission, where we also have an orbiter, but also had a Vikram lander, a Pragyan rover inside it. We all know that the lander could not do successful soft landing, though it performed all its activity right from the launch till about a kilometer above the lunar surface.
Yes, sir.
And therefore, the technology which was developed for the soft landing, many of those got validated in that. And that gave us confidence for the Chandrayaan 3 mission. But if you look at the orbiter of the Chandrayaan 2, it is working since last 5 years. And with 8 experiments on board, it is providing us excellent quality of data. And yes. Therefore, somebody asked me is Chandrayaan 2 a failure? I say no, it is a huge success.
Yes.
The orbiter is working very well, so 100% success there. The lander also worked till almost like a few hundred meters above the lunar surface. And it was exactly going on the same path in which we were thinking it will go.
Right.
So the technology required for such kind of soft landing is not very easy, and no other country gives you. And you have to develop of your own within the country. Now, if you talk about the contribution of the Chandrayaan 2 orbiter to the Chandrayaan 3 landing, there is an instrument called OHRC on Chandrayaan 2 orbiter, which is optical high resolution camera. And this high resolution camera has the resolution of about 1 feet or 30 centimeter from 100 kilometer.
That's huge.
So it actually gave us a lot of new information about the terrain where we should do the landing. And therefore, the Chandrayaan 3 landing site was actually decided by the data from our own orbiter Chandrayaan 2 instrument.
Right.
And it was different than the Chandrayaan 2 landing site. So Chandrayaan 3 landing site is different than the Chandrayaan 2 landing site. It was decided based on this orbiter.
Sir, you explained very well. And obviously, Chandrayaan 2 is not the failure. You explained it very well. Sir, nowadays, you know that India has been a surge in space-based startups in recent years. What role do you think these startups play in broader space ecosystems? And how can they complement the effort of establishment organizations like ISRO and PRL?
As you must have seen already, that government of India has given a lot of boost to private players.
Yeah.
And of course, the startups. And I see every day young and bright mind coming into this area of space ecosystem or space science, space technology, space infrastructure development. And this is all possible because the government of India has looked up space not just for R&D, but also for exploration in terms of economical development.
Right.
Now, there are limitations when you talk about the government setup, like so government of India wants that new players should also be there, including private players, startups, and things like that.
Right.
Of course, private players have been there throughout in the whole system of exploration by ISRO, because 70 to 80% of the work is actually still done in industry and in the private sector, right? But
Right.
now, government wants and the whole country is interested that we should multiply this. When you talk about multiplication, you need a lot of hands to work together. And there comes the role of startups and private players who are now coming up.
Right.
Whether it is an area of rocketry, whether it's the area of satellite development, or the area of application, or even the exploration. And therefore, whole world is looking at India in a very different way, because India is not just one among the few nations in the world who has this capability, but India has a lot of talent. And that talent with young generation minds and the capabilities which exist within the country in terms of both financial power and the mind power, that India can actually contribute significantly in the world space ecosystem.
Right.
And therefore, I would really like to urge all those who are listening to this conversation that you are most welcome to contribute in the way you want to do. Because I will tell you, we need not just people from aerospace or electronics or communication and things like that. People are required, or basically the training is required from entire system.
Right.
Whether it is engineering side, technology side, science side, social science side, biological science, medical science, law, management, everybody is required. We
Right,
talk
sir.
about space law nowadays. We talk about space management. How do you manage the system, right? So, and then we talk about what you call space medicine, space food, because once astronauts are going to space, you should know what they are going to eat in space, right?
Right.
And therefore, entire ecosystem is being driven by the space sciences. And
Right.
therefore, people are required from entire community, from any area, can come into the space science.
Yes, sir. Yeah, wonderfully explain it. So, do you think it is possible that some of the recent space startup could become unicorn in the near future? What is your opinion on this? Because lots of unicorns race is going on in India. So, what is your opinion on this?
Everybody is going to make their own contribution. Everybody is going to make their own niche in this area. And therefore, as you know that, for example, when a new shop or a new mall is opened in the city, people think who's going to go there, right?
Yeah, yeah.
But you see that they are still contributing and people are going there. So everybody's ambition and everybody's entrepreneurship is required because the way they think is different.
Right.
And therefore, the way they are going to contribute in the whole ecosystem of a space science or space technology or space infrastructure will be different. And there are many, many areas in which people can contribute. People with different areas can contribute. And therefore, everybody has its own ways of contributing. And I would urge everybody to think about it seriously in this direction.
As the director of PRL Ahmedabad, could you highlight some of the recent contributions of PRL to space research, and what are some of the exciting projects currently underway at the PRL?
Okay, so when you talk about PRL, let me also tell you that PRL is one of the very old institute in India.
Yes. Yes, sir.
It was established in the year 1947, very soon after we became independent, on 11th of November 1947, by Dr. Vikram Sarabhai, who is also considered as the father of Indian space program, essentially because he is the one who actually started the whole space research and space science program in the country. Whether you talk about the rocketry program, you talk about the satellite program, you talk about the application program, everything was started under his leadership. And therefore, PRL is called as the cradle of space science in India. And PRL still contributes very significantly into space science and space research in the country. The major domains currently in research in PRL are astronomy, astrophysics, where we also contribute to exoplanet.
Right.
In fact, PRL is the only institute in the country where we have discovered exoplanets. In fact, now 3 exoplanets have been discovered by India, and all 3 are done by PRL using its own 1.2 meter telescope at Mount Abu and an instrument called PARAS, which is indigenously developed in PRL. Now we have 2.5 meter telescope commissioned at Mount Abu. And we have also developed an instrument called PARAS 2, which is a next generation of PARAS. And with that, we have again discovered the 4th exoplanet. And I can also vouch to say that PARAS 2 is actually the highest resolution spectrograph within Asia. And it is among the 6th in the world. So this kind of capability exists in PRL scientists and engineers and professors who have developed this. We are working in the area of planetary exploration, as you all know. So we have contributed in Chandrayaan 1, Chandrayaan 2, Chandrayaan 3. We had an instrument on the rover as well as on the lander. And excellent science has come out from that, including knowing about the elemental composition at the Shiv Shakti point, which is the landing site of Chandrayaan 3 Vikram lander.
Yes, sir.
And this paper is getting published in Nature. And Nature has accepted it because it is the first time we are coming to know about what is present at such high latitudes. We are also working on Aditya L1, which is an instrument or basically observatory at L1 point, where we have an instrument called Aspects, which is actually providing us the data about the solar wind and CMEs coming at L1 point from the sun. And we have seen its performance during the very recent solar event in the May, around 8 to 12 May. There was a huge solar storms and CMEs were ejected and flares were happening and whole world was affected. And we could very clearly see the signature of how the solar wind charged particles enhancement took place, which we found to be more than an order of magnitude change. We are working in the area of quantum communication. we have shown or demonstrated free space quantum communication over 200 meters. We have developed protocols, BB94, BB82, of quantum key distribution and demonstrated how it is possible. And in fact, we have actually demonstrated with the help of a project of DOT, that is Department of Telecommunication, to show that how this free space quantum communication with the key QKD can be clubbed to fiber optics cable, and shown that the signals over 200-meter free space with QKD can be decoded in Delhi from Ahmedabad.
Yeah.
And then in the area of space sciences, we are talking about a new mission called Disha, which is going to be in an orbit around the Earth somewhere around 450. It will be twin aeronomy satellite mission, which will go into polar and equatorial orbit. And that will help us understand how this space weather activities affect the planet Earth in much more detail than we know right now. Because space is involved in our daily life in such a way that we don't even realize.
Right.
Communication, right now I'm talking to you, there's a space sector which is involved in this.
Yeah.
Right? And whether we talk about the mobile, we talk about the internet, we talk about data from one place to another place. We saw so many channels worldwide coming on our TV sets. They're all possible because of the space. And not only this, our ATMs, whole economy of the country is driven by the space.
Right.
Therefore, we should know what are the consequences or the impact of any natural events happening on this. And therefore, this Disha mission is going to be very, very useful. We are also working in the area of geosciences, where we talk about how the climate changes are happening, how the weather patterns keep changing. So clubbing the information of the atmosphere and the ocean and the land, and how their interaction or exchange takes place, both in terms of the heat, the momentum, the wind pattern, and things like that. We try to understand how it is going to affect the planet Earth. So we have colleagues who are working in the area of geosciences, both in oceanography, biogeosciences, paleoclimate science. We have colleagues who go to Arctic and Antarctic or into Himalayas to collect samples and study in our labs. So we have more than 40 labs within PRL where we do analysis of various samples which is brought, whether it's a rock, whether it's a water, whether it's a ice, whether it's a coral reef, whether it is any organism which is dead now, or even, for example, tree trunks. Similarly, we have colleagues who are working in the solar physics who look at the processes happening on the sun, because ultimately sun is the head of our solar system. And we should know how things happening on the sun affects the planet Earth through the process of space weather. And therefore, we have a telescope in Udaipur, in the Udaipur Solar Observatory, which is a 50-centimeter telescope, which is the largest solar telescope in India. And they look at the sun continuously in the daytime to look at the process which is happening, and how do you club that kind of information with, for example, Aditya L1, and of course, the satellite around the Earth. Then we have colleagues who work in the area of atomic molecular optical physics, where we look at the processes which happens at femtosecond or attosecond time scales. And we use different kind of lasers to control this kind of processes, and to see what kind of processes can give rise, or what kind of chemistry or what kind of reactions can take place in this kind of time scales. We also look at what you call luminescence dating, which is essentially trying to understand the processes which has happened several hundreds to thousands of years back, or even millennia back. And then we have colleagues who work in the area of theoretical physics, high energy physics, quantum processes, and also looking at superconductivity, or I should say different kind of processes giving rise in metals, which
Right.
would change our understanding in terms of their behaviors, properties. So these are very broad areas of research in which colleagues in PRL are working.
So you describe very well about PRL, and it's always a prestigious institute for us. And in your guidance, its legacy is always maintained. Uh, Sir, I'm moving to the next question. ISRO has made remarkable progress over the years. What do you think are the key factors that have contributed to the recent boost in Indian space programs? And how does ISRO plan to maintain and accelerate this momentum in coming years?
Okay, so this is a bit of a broader question of how ISRO is functioning. From my perspective, when I look at how things are happening within ISRO or Department of Space, I can say that the focus is on exploration.
Right.
In addition to the R&D work which is being carried out, whether it's a rocketry area or a satellite area or application area, the focus is on exploration, which is one of the big target which is given by Government of India to Department of Space or ISRO, that we should have a series of missions going to the moon, starting with the Chandrayaan 4, 5, 6, and 7, with Chandrayaan 4 being a sample return mission.
Yeah.
And also, the mandate is that India should have its own space station, that is the Bharatiya Antariksha Station, and Indian Vayonauts should land on the moon somewhere around 2040. Now, if you look at this target, it has two components. One is human exploration, so human beings are involved directly. Second is technology development.
Yes.
And third is exploration. So all these three has to be jived and synchronized to achieve these goals, where we talk about Gaganyaan, that is the program in which Indian astronauts will go into space around the Earth, and slowly we will start extending that to ultimately go to the moon. This also involves a lot of technological development, whether it is a rocketry program, whether it is a technology to safeguard the humans when they go into space. For example, space suits, the capsule in which they go, right? The equipments they need to carry with them, the life support system they should have, and how can you sustain that in the future for a longer mission.
Right.
So there's a lot of synergy between different technology which is getting developed within the country. It is not just within ISRO, I should say. There are many private players, there are many public sectors, many private government agencies who are working together for doing this kind of activities, because it calls for the whole nation to come together to achieve this. And it also gives back in turn to the country also. Right. It is not just the supremacy, it is strategic use, it is technological development which has spin-offs, and they are being used in many other sectors. So if you look at holistically the space program, I should say it is one of the programs where people from all branches of science, technology, social science, economics, psychology, even human psychology, right?
Yeah.
If an astronaut goes into space, and that follows, how does he start thinking in isolation, right? So psychology also comes into picture. So there's a whole branch of art, science, literature, everything comes together to do the development, and which is also very much required if we have to achieve this larger goals which is set up by the government of India.
Sir, with the increasing frequency of satellite launches, the issue of space debris is becoming a growing concern. How do you perceive this risk associated with the space debris, and is India taking any steps to address this issue to prevent potential catastrophic event in the future?
Yeah, this is a very good question, because this is what everybody starts thinking nowadays, that when we are doing so many launches, what is going to happen to the space? Will there be a traffic jam in space, right? Of course, space is huge, so I don't think that is going to happen in the next few decades or even centuries. But the issue of collision is certainly there. And therefore, ISRO also has a program where we keep watching various satellites and their movements and their locations. And whenever we do our launch, we see to it that in the path of the rocket, when it is going up, or when the spacecraft is the launcher is releasing the satellite, there is no other object in the vicinity, no other satellite or any other object. We also have a program called Space Situation Awareness, where we keep monitoring any other satellite movement closer to our own satellites, or any hazards which may be created by having any dead flying object coming and hitting our own space assets. And this is a regular activity which is being carried out by all spacefaring nations, including India. And we do share information among each other, because ultimately it's a joint effort which has to be carried out in space by all spacefaring nations.
Right.
So this is one of the activity which is being carried out. But we are also worried about the junk which is lying in space.
Yes.
And how can we overcome that in the future? Because if we keep on adding junk, ultimately it will become an issue for all of us. And therefore, one of the ways in which ISRO is dealing with this is to have the spacecraft very close to the end of its life. Use the small amount of fuel should be left out, so that you can move that spacecraft into an orbit so that it starts decaying and come closer and get burned up. So that's one way in which you actually, make space for others to put the satellites. And we all know that a small spacecraft, when it is coming down, it will essentially burn up somewhere around 100 to 150 kilometers above the surface of the Earth because of the frictional heat. If there are issues with respect to anything which is larger or could not be burned up, then there should be provisions of making it fall into an area which is not manned or where there is no habitat. And therefore, there are protocols which various international space agencies like United Nations Office of Outer Space Affairs or Peaceful Use of Outer Space Affairs are there, where we have to follow those guidelines and to take care of our own assets in space, and also that when we do the rocket launch, that we are not going to hit or hurt anybody else. So there are protocols, there are regulations for this, but we are also working on how do we make our space cleaner so that we don't keep accumulating the junk there. And therefore, those protocols are also getting in place, not just for spacefaring nations, but also for private players. As you must be seeing now that there are many private players which are launching their own space assets or launching their own satellites, even including landing on the moon. And therefore, these regulations are going to be applicable for everyone.
So nicely, you explained nicely. So before this talk, I asked lots of students which question you wanted to ask. So most of the student asking said, "Do you believe in aliens?" This is the most exciting questions for all.
Okay, so it's a difficult question in the sense that I should put it other way around. That do I believe that life exists at any other place other than on planet Earth? And I say yes. I do believe life would be, or is currently existing on any other planet within our own solar system or outside our own solar system. Essentially because if you look at exoplanets, for example, and right now we know probably more than 5,000 exoplanets have been discovered, right? And so what is so unique on the planet Earth that the life could exist?
Right.
And I'm not talking about life like me and you. I'm talking about the life which reproduce. It could be amoeba, bacteria, virus, single cell. It could be plants, right? Or a very, very advanced life like us, human beings, right? So existence of life on any other planet other than Earth, within our solar system or outside our solar system, I would say yes. Now, the question comes, how do we know it?
Right.
And we are all trying to look within our own solar system and say, oh, Mars could have life in the past, or even now, for example, because water has existed on the Mars in the past. We know the Mars was hot and wet in the past. Now it is cold and dry. We talk about life on Europa, a satellite of Jupiter. We talk about life on Callisto, or life on what you called the satellite of Saturn, where we are seeing geysers coming out. So that means there is a fluid inside. If fluid is there and heat is available, there is a high chance of amphibian life, either totally living in water or partly living in water on the land. So life, I believe, yes. What form of life, we still do not know. But outside our solar system, also, I believe life should be there, because we are seeing different stars in the different stages. Our own star is now 4.5 billion, because our own solar system is 4.5 billion years, right? And we know that it will live for another 4.5 billion years. So if you look at the age of the star and the stage of the star, there are many stars which are just born. There are many stars which are grown up. There are many stars which are in adolescent. There are many stars which are full age, and some of them are decaying. So that means the planets around that must have at least some form of life.
Right.
Now, whether these aliens are actually highly intelligent life form which are coming from them, from those planets, it's a question which is very difficult for us to understand, because we are not seeing any signals from any aliens sending to us, or at least communicating that we know. And because we know that speed of light is the fastest way in which the signals can go, right? Even in vacuum.
Right.
So how this, or they are too intelligent than us, that they are not able to, or they are actually hiding things from us, but they are visiting us. So it's a mystery. It's a mystery. Sometimes it is optical illusion, which we turn it to be alien, and sometimes it could be something which we still don't understand.
Sir, as you mentioned that sun has a limited age, so is in future or far future we are planning to move long distances in our in our galaxies or in our solar systems, because we need to be moved ahead if we wanted to survive. What is your opinion on that thing?
That is too far off from us right now, because that will be several billion years later.
Right.
Only thing, if we have to explore anything beyond our solar system, the biggest issue is how fast we can move,
Right.
and how fast or how strong our launch vehicles can be, which can send these spacecrafts across our own, beyond our own solar system, or beyond our own heliosphere, I should say.
Right.
Because sun has a huge cocoon, which we call as a heliosphere. Under the influence of the sun, and there is a huge magnetic region, which or gravitational pull region, which is controlled by the sun. So you have to come out of that, and it will take several decades for us to cross that, right? We have seen Voyager crossing 100 astronomical unit in close to 30 years, right? So it will take a huge time to move from one star to another star, or the nearest star, I should say, right? And that will be more than the lifetime of a human currently, as per the current limitations of the speed at which we can travel. And therefore, it becomes very, very difficult that how this can be achieved, that we move from one solar system to another solar system. But we don't know. Maybe in future we may have some other ways in which we can move faster than what we can do now. And that time it may be possible for us to move to other solar systems.
Right. Sir, as you involve in Mars missions as well as, sir, is there any upcoming missions are lined up, or what's going on, sir, on the Mars?
So I just told you the story about the moon exploration. So that is very much there. And that is there for next 30, 40 years. We have to keep on doing this. We are also talking about mission to Venus. We are talking about next mission to Mars. We already had a mission in the past called Mars Orbiter mission, which was launched in 2013. And we reached the Mars after 10 months of travel in 2014 on 24th of September. And we continued to work for 8 years, though the mission lifetime was just 6 months. So we had a very successful Mars mission.
Yes.
Now our idea is not to go in the same mode of an orbiter, but we should do landing. And not just landing like on the moon with a lander, but we should directly land with a rover so that we can move on the Mars. Because Mars has been explored quite a lot, and if you have to make a niche in the science in the area of Mars exploration, we should move around rather than sitting at one place and doing the science. And therefore, the plan is to do a landing with a rover on the Mars. We are also talking about exploration of Phobos, which is a small satellite of Mars, moving around it. And in the future, we are talking about not just planets, but also comets and asteroids. And to the outer part of the solar system, like going to Jupiter or Saturn. But of course, it will take time because the travel time itself is very, very large. If you're thinking about exploring the Mars, it takes 10 months, 6 months to 12 months, I should say, for reaching Mars. Reaching Venus will be also a bit difficult because it is the inner part of the solar system than Earth, and therefore the sun pulls when you send the spacecraft. So you have to take time to go around to reach Venus. It may take more than a year to reach Venus. So when you're talking about exploring the outer part of the solar system, it will take several years for you to launch and reach there and do science. So that means the gestation period is very large, and therefore we need a series of scientists working together over several years, or I should say several decades, for bringing out excellent science from this kind of missions.
So, sir, as you know that IIT Indore recently launched a Btech program in space engineering. How do you see this program contributing to the future of space research and industry in India? And what opportunity do you think it will open up for students? And do you believe we need more programs like this in our other institutes?
Of course, I was just telling you that we need more and more people to come into the space program. And IIT Indore has started this new department of space science and space astronomy and exploration, which is going to feed into this space program of the country. And we need more scientists, more engineers, more young blood to come into this exploration, or I should say space economy and space ecosystem, to contribute in their own ways. It's not a single way in which you should all do in this way. There are many, many ways in which you can contribute. And I'm happy that I'm talking to you, who is a bright student working in this area at IIT Indore. And through you, I am communicating to a very large number of students within the country to motivate them and to take up space science and space exploration within the country. There is ample scope for everyone to do that, and therefore you have to choose the way in which you want to do it.
Sir, thank you for your kind words. Sir, one more question which is very common when I ask to students for this talk, that they are a little bit wanted to know about the Lagrange point in Aditya L1 lesson. Lagrange point.
Lagrange point. Okay.
So can you simplify for the student of school students what is Lagrange point?
So L1, which is called the first Lagrange, it is a point, is an imaginary point between Sun and Earth on a line joining Sun and Earth, which is about 1% away from Earth and 99% away from the Sun. So it is very close to the Earth. Okay. But to give you a feel how far it is something like 4 times the Earth Moon distance.
Okay.
So if you say Moon is about 4 lakh kilometers, this is something like 15 lakh kilometers, 16 lakh. That means the sun Earth distance is 150 lakh, right? So
Right.
it is very close to the Earth. But the advantage with the L1 point is that if you put a satellite there, which is an imaginary point, it will move around the sun as the Earth is going around the sun. And therefore, you can use that satellite to continuously look at the sun, which is not possible when it is orbiting the Earth.
Right.
Because at some point of time, it is behind the Earth. But here, it is right in the front of the Earth and looking at the sun, and it is going around the sun, not around the Earth.
Right.
And therefore, it is called 24/7 observatory because it can see the sun 24/7.
Yes, sir. You explained nicely. Sir, at last, sir, there's a last question. For student aspiring to build a career in space research or engineering, what advice would you give? What skills and experience should they focus on to succeed in this field?
Okay, so this is very much linked to what I was already told you earlier also, that we need people from entire community,
Right.
whether it is science, technology, engineering, medical, biology, botany, geology, geology, social science, economy, law, management, whatnot. Only thing is you have to create your own niche of how do you contribute. Of course, we need a lot of people with engineering background because there's a lot of R&D, technological challenges and technological development. And therefore, we need people from mechanical, electrical, electronics, metallurgy, propulsion, computer science, civil, all branches of engineering, all branches of science, physics, chemistry, math, biology, geology, geography, and then, of course, people from economics, people from sociology, people from medical science, people from biological science, people from food science, people from psychological. So, entire system of science of sciences
Right.
is required in the area of the space science and technology. And therefore, everybody can contribute in its own ways.
Yes, sir. So thank you for sharing your insight and experiences with us today. Your words have undoubtedly inspired many of us to explore the limitless possibilities in the space research engineering. We look forward to seeing the continued success of PRL, ISRO, and IIT Indore, the Indian space program as whole, sir. Thank you, sir.
Thank you, Saurabh. And it was wonderful talking to you. And through this, I believe that a lot of students will be inspired to take up the challenges of a space exploration and contribute to the space ecosystem within the country. Thank you.
Yes,
Thank you
sir.
very much.
Thank you, sir.
Take care. Bye-bye.